We're starting Chapter 8, Roots and Radicals. This is from OpenStax Intermediate Algebra book. So let's talk about some things that you should have already learned. We haven't done it this year, but you should have learned this in Algebra 1 or even some in pre-algebra. So go ahead and pause the video, take this readiness quiz, and then we'll discuss these concepts. You should have paused the video and gone through these. Let's go ahead and go through them together and see how ready you are for the concepts that we are going to be doing in this chapter. So first, you had to simplify, and we're simplifying with powers. And so negative 9 squared is equal to negative 9 times negative 9. And there are multiple ways to write that. But we all know that a negative times a negative is a positive, and 9 times 9 is 81. And so that's how you would solve that one. Now, if there's no parentheses, what this means is negative 9 times 9. And so in this case, we have one negative, and so the answer is going to be negative, and 9 times 9 is 81. So these two expressions represent the opposites of each other, positive 81 and negative 81. Now we have negative 9 in parentheses, but we have it cubed. What this means is negative 9 times negative 9 times negative 9. And so we have 1, 2, 3 negatives, which means our answer is going to be negative. 9 times 9 is 81. And then if we multiply that times another 9, we get 729. So these are the answers that you should have gotten for these first three. Rounding to the nearest hundredth. So we're going to look at our 100th place number, and we have a 4 there. That's where we're rounding to, but we need to take a look at the thousandths and decide what we're going to do. Because the thousandths place is a 6, that is more than halfway between 400ths and 500ths, we're going to round up. So your solution here should be 3.85, rounded to the nearest hundredth. Okay, and simplify. X to the third times x to the third. Think back to when you learned about the principles of powers. And so x to the third times x to the third is equal to x to the third plus 3. Remember, when you're multiplying like bases with exponents, you add the exponents, okay? You're multiplying these, but you add the exponents here. So this is equal to x to the 6th. And then same thing with the y's, we're multiplying these, so we're going to add all the exponents together. So that equals y times to the 2 plus 2 plus 2, which equals y to the 6th. And for our z's, we get z to the 3 plus 3 plus 3 plus 3, which is equal to z to the 12th. If you didn't get these and you don't remember these concepts, please let me know. I will direct you to some resources for you to review these concepts. So let's go ahead and get started with simplifying expressions with roots. First, we need to come up with some definitions. We have the square and square root of a number, and we are going to go ahead and define these. We have this expression, we have an equation, n squared is equal to m. If n squared is equal to m, then m is the square of n. Okay, so m is the square of n. And n is the opposite of that, which would be square root. I shouldn't say opposite, I should say the inverse. N is the inverse of that. N is the square root of m. Square root. So square and square root are inverses. Just as addition and subtraction are inverses, multiplication and division are inverses. Square and square root are inverses. So if we are to look at how we talk about these things, Um, 13 squared, we read, well, 13 to the second power, we read as 13 squared. Hopefully you guys are familiar with that. Also, 169 is called the square of 13 since 13 to the second power is equal to 169. So you can see this format is just translated down here, but with numbers. And so because 13 is squared, then that means that 169 is the square of 13. And 13 is the square root of 169 because it is the number that is squared. So taking that last one that we just had, 13 squared is equal to 169. Notice though that we can also say that negative 13 squared is also equal to 169. Okay, because when we square a negative, it gets rid of that negative and it becomes positive. So therefore, what this means is that each square has two square roots. So let's go ahead and write that out. We can say every positive number has two square roots. Okay, so the square roots of 169 are positive 13 and negative 13, right? And so we've done this before where we've taken the square root and we had to take the positive and the negative, and that's also in the quadratic formula. And so keep that in mind. Every positive number has two square roots. Oh, I had written it there. The principal square root is the positive square root. A lot of times you're only interested in the positive, you don't care about the negative. For example, if you're trying to find the hypotenuse of a triangle and you're using the Pythagorean theorem, you're going to have to take the square root, but the side of a triangle can't have a negative measurement, and so you're only concerned with the positive value, and so in that case we use the principal square root. And so let's talk about square root notation. How do we notate square roots? I know you guys are familiar with this, but let's just go ahead and write it down. So this is the square root symbol, right? And this is, we would say this as the square root of m. Sorry, I'm misspelling here. The square root of m. Okay, and what this means is that if n squared is equal to m, then we're going to solve for n. N is equal to the square root of m. Okay, so these are the same equations, but one is solved for n and one is solved for m. But this is only true when n is greater than or equal to 0. So let's talk about the parts of a square root. So I'm going to rewrite it right here. The m, or whatever value or variables you have under there, anything that's inside the square root is called the radicand. And the symbol itself is called the radical sign. The radical sign. We can call it a square root symbol, but it's not always going to be the square root. We might have the cube root or higher powers, and so the generic term is just the radical sign. So what if we want a negative square root? If we are concerned with the negative, then the negative sign goes on the outside. So the negative sign goes on the outside of the radical symbol. And you, as I mentioned, you have seen this in the quadratic formula. What does x equal? X equals negative b plus or minus the square root of b squared minus 4ac, and that's all over 2a, right? So here we want the positive, the principal square root there, and we want the negative, so we have to put that negative outside in order to find the negative value of that. What number has only one square root? I said that all positive numbers have two square roots, the positive and the negative. Think about what number would only have one. That would be the square root of 0, right? The square root of 0 is 0. There's no such thing as positive 0 and negative 0. So 0 is the only number that has only one square root. So let's do some examples together. First, simplify the square root of 144. So what this is asking is we want to know what number, let's call that number A, what number when squared is equal to 144. We can also say what number times itself is equal to 144. And this is where your times tables are going to come in handy. And it is, I will suggest that you memorize some of these squares and square roots. But your times tables are really going to come in handy for this. So if you remember back to your times tables, you will remember that 12 squared is equal to 144, or 12 times 12 is equal to 144, right? Those are the same things. That's two ways to show the same exact equation. So therefore, the square root of 144 is 12. Okay, the square root of 144 is 12. Let's look at this one. Negative square root of 289. So we want to know what number squared is equal to 289, or what number times itself is equal to 289. In this case, this is one that you probably did not memorize with your times tables because the answer is 17, and usually you just memorize up to 12 or 15. But 17 times 17 is equal to 289. So we know that the answer to this, now it's going to be negative because we want the negative square root, we don't want the principal square root, is negative, and the square root of 289 is 17. That is your answer. So let's look at some try it problems. Go ahead and pause the video here. Go ahead and work these out on your own piece of paper and then come back to see if you solved them correctly. Let's go through this. So we want to know what number times itself or squared is equal to 64. And so this one you should have memorized with your times tables. 8 times 8 is equal to 64. And we know that we're looking for the negative, not the principal square root. So we're going to put a negative, and then the square root of 64 is 8. So our answer is negative 8. Square root of 225. So we're asking ourselves what number times itself is equal to 225. Once again, one that you probably didn't memorize, but you can try to figure this out. We know that 12 squared is equal to 144, so it has to be more than 12. We know that 20 squared is equal to 400, so it has to be less than 20. And then you can try numbers within there. Eventually you'll get to 15, and 15 squared is equal to 225. So we know that we're looking for the principal square root, not the negative. So the answer to this is going to be 15. The square root of 225 is 15 because 15 times itself is 15. If you didn't get those correct, go through and watch again and make sure that you're understanding how you are supposed to solve these. So here's another try it. So go ahead and pause the video, try it on your paper, and then come back. We'll go ahead and solve these. So we're asking what number times itself is equal to 100, and hopefully you all recognized that the answer to this one is 10. 10 times 10 is equal to 100. Now we have a negative. We're taking the negative, so we can just go ahead and plug the negative in over there. And then what number times itself is equal to 121? This one was in the times tables that you memorized, and that answer is 11. 11 times 11 is 121. So this negative square root of 121 is negative 11. Check your answers and make sure you understand why we got the answers that we got. So let's talk about negative square roots, and hopefully you remember this, but if not, we'll review it. What happens when you get a negative inside a square root? And so let's look at what this is asking. It's asking what number times itself, sorry, let me get a dot there, times itself is equal to negative 49. Okay, what number times itself is equal to negative 49. So let's think about this. If we had a positive number, we would have a positive number times a positive number, and we know that that equals a positive number. So let's put negatives in there. If we have a negative number and we multiply that times a negative number, we know that a negative times a negative is a positive. So there's no number that we could put in here and multiply times itself that would equal a negative number. So what this means is that the solution to this is not a real number. Not a real number. Now, we will eventually get into how to deal with these negatives inside a square root. They're called imaginary numbers. We will get to that. But for now, just know that it's not a real number. Technically, the answer is not no solution, but at this point, since you don't know how to deal with that, you can go ahead and say that the solution to this is no solution, because you have not learned how to deal with that yet. So anytime at this point you see a negative sign inside the square root, the answer is going to be no solution. So, oh, I skipped one, there we go. Let's do some examples with that concept. We have the square root of negative 196. Now what did we just learn? We learned that if there's a negative inside the square root, that there is no solution to this that you guys are able to handle right now. So you're going to put no solution, or you could say not a real number, because there is a solution, it's just imaginary. Not a real, number. Okay, so let's look at this one. Here the negative is outside, not inside, and so we can do this. If the negative is outside, we move the negative over there, and then we ask what number times itself is equal to 64, and we know that that solution is 8. So the negative square root of 64 is negative 8. Let's go ahead and have you do some try it problems. Pause the video, come back and check to make sure that your answers are the same. A, we have the negative inside the square root, so we know that that is going to be no solution or not a real number. But B, the negative's on the outside, so we can deal with that. We're going to put the negative over there on the other side of the equal sign, and then ask ourselves what number times itself is equal to 81. The answer to that is 9. So the negative square root of 81 is negative 9. Check your answers and make sure yours match. Here's a couple more try it problems. Pause the video, try it on your piece of paper, and see if you get the same answer as me. A, the negative is on the outside, so we just move it over. And then what number times itself is equal to 49? 7 times 7 is 49, so our solution is negative 7. B, our negative is back inside the radical sign, the radical symbol, so we know that at this point that is not a real number. And I gave you permission to say no solution at this point. And check your answers, make sure you are understanding this concept correctly. If you need to go back and rewatch it, please do. So we've been working with square roots and squareds, but there are higher powers and higher roots. And I know you guys are familiar with this. We've worked with some of these this year. So let's see what these are. N to the 2, which we've been working on, is called n squared. But n to the 3 we call n cubed. And I know you guys are familiar with this, but do you understand why they are called squared and cubed? Why did we why do we call a power of 2 squared and a power of 3 cubed? Well, it all comes from some geometry, right? If you have a square, we're going to pretend that that is an actual square with all 4 sides the same measurement and 90-degree angle corners. But if we have a square and the length of one side is A, in order to find the area of this, we square the length of one side. That's why we say squared, because that's how you make a square. You take one length and multiply it times itself and you get a square. With cubed, we take that one more dimension. So if you have a cube, pretending that these are all squares, we're going to make our cube, right? To find the volume of the cube, let's say that our length of one side is B. To find the volume of the cube, we take the length of that one side and we cube it. 3, put it to the third power, right? Length times height times length times height times width. And so that's why we use the terms squared and cubed, because that's how we get the measurements for those shapes. So keep that in mind, just to help you remember why we use those terms. But we also have higher values of exponents. N to the 4th power, there's no special term for that. We just say n to the 4th power, n to the 5th power, and then so on and so forth. Above 3, there's no special name. You just say n to the whatever power. So here we have a chart with the first few powers of some numbers and some variables. So these are the numbers, and here we have this one. We have the square, the cube, the 4th power, and the 5th power. And so we have the generic n squared, n cubed, n to the 4th power, n to the 5th power. And then we get into plugging some numbers in there. N, or 1, if we replace n with 1, 1 squared is equal to 1, because 1 times 1 is 1. 1 cubed is 1. 1 to the 4th power is 1, right? Anytime you multiply 1 times 1, it doesn't matter how many times you're going to do it, you're always going to get 1. So let's look at 2. 2 squared is 2 times 2, that equals 4. 2 times 2 times 2 equals 8. 2 times 2 times 2 times 2 is equal to 16. And then 2 times 2 times 2 times 2 times 2 is equal to 32. And then when we get down here, we get some variables just showing how you just change the variable there. It is highly recommended that you memorize some of these values. The 2's you're going to see a lot. I'm actually going to have you play a game with the 2's. The 3's you will see a lot as well. I would at least suggest memorizing up through 81. 243 not as much. For the 4's, definitely memorize at least to 64. For the 5's, memorize at least to 125. Those are going to be very helpful to you as you do work on these problems and work with even further, not just for this unit or this assignment, but further into your math careers. It's going to be very helpful if you have some of these memorized. So let's pull up a different chart here. This one is replacing n with negative numbers. So in the previous one, we had all positive numbers. Now we put in negative numbers. Let's see what happens. So our n's are all negative. When we square it, because we're doing a negative times a negative, all of the values are positive. But then when we cube it, we have a negative times a negative times a negative, which means all the values are negative. When we go to the 4th power, once again, those negatives disappear because we have a negative times a negative times a negative times a negative, and all the negatives disappear. Then going to the 5th, the negatives show up again. So the important thing to note about this, go ahead and write this down. If n is a negative number, if n is a negative number, even powers, okay, so squared or to the 4th, even powers, even to the 6th, the 8th, they yield a positive result. And odd powers to the first, third, fifth, and so on and so forth, odd powers yield a negative result. Okay, so I'm going to say that one more time. If n is a negative number, even powers yield a positive result. Odd powers yield a negative result. Okay, so keep that in mind. That is very, very important to remember. So let's go ahead and give a definition to the nth root of a number. The nth root of a number. I don't remember if I have. No, I don't have it typed here. I'll have to write it out for you. The nth root of a number. If b to the n is equal to a, then b is the nth root of a. Remember our definition of square root? We had a 2 up here, and we also used n and m, but we said that this b would be the square root of a. Now we're just changing it to say the nth root. If b to the n equals a, then b is the nth root of a. And the way we would write this is b is equal to n and then the radical symbol of a. Okay, so you put your nth root number there and the radical symbol. With square root, we know that if there's no number there, it just means square root. And then this is how you find the principal root. Principal root. So the positive one. In this case, n is referred to as the index of the radical. You might not hear that term very often, but in your assignment it might use the word index. What is the index of the radical? Just know it refers to that little number that's floating in front of the radical symbol. So let's go ahead and look at some of these. Let me go ahead and pull up all my examples here. So we have 4 to the third power is equal to 64, and so if we want to write this in not square root, in nth root notation, it would be written like this. 4 is equal to the third root of 64. Okay, so see how the 3 moves over to the other side as the nth root. For 3 to the fourth power equals 81, 3 is equal to the fourth root of 81. Negative 2 to the fifth power is equal to negative 32. So because we have an odd power here, we keep the negative. So negative 2 is equal to the fifth power of negative 32. And always make sure your radical symbol goes over everything that you want inside there. I do take off points if your radical symbol doesn't cover everything that it's supposed to, or if there's something extra that shouldn't be in there. So look over those, make sure you understand that, go back and review it if you need to. So let's look at the properties of the nth root of a. When n is an even number and a, so when n is an even number, and we're taking an even root, and a is greater than or equal to 0, then n to the nth root of a is a real number. However, if n is an even number and a is less than 0, which means a has a negative symbol on it, then the nth root of a is not a real number. Right? So for example, if we had if n is an even number, let's take the fourth root of let's just do 100. Okay, then this is a real number because a is greater than or equal to 0. But if we have an even root and it's a negative, because we have that negative inside and an even root, then it is not a real number. However, when n is an odd number, let's say the fifth root of 100, then the nth root of a is real for all values of a. It doesn't matter what a is. So we could have the fifth root of positive 100. We could also have the fifth root of negative 100. As long as you have that odd number here, you can have a negative inside. Let's do some examples together to make sure that you are understanding this. So for the cube root of 64, we are asking what times itself is equal to 64. So what would be the value of a that we could put in there that would equal 64? Now, the chart that was on slide 14, that would just back a few minutes, would be very helpful for this. And this is the chart I said you might want to memorize. So if you go back and look at that chart, you will see that if we put 4 in here, 4 times 4 times 4, that will equal 64. So the answer to the cube root of 64 is 4. What about the fourth root of 81? What times itself 4 times is going to equal 81? So once again, you could go back to that chart and look at it. But I know 81 is only divisible by a few things. 9 and 3 are two that pop up. So I know it's not 9 because 9 times 9 is 81. Let's try 3. 3 times 3 times 3 times 3. That equals 9 times 9, which equals 81. So therefore, the fourth root of 81 is 3. What about the fifth root of 32? If you go back and look at your chart, you can find it there, or you can just think what times itself 5 times is going to be 32. There aren't very many options. It has to be an even number. I'm going to try 2. 2 times 2 times 2 times 2 times 2, and then I can simplify this as 4 times 4 times 2, which is equal to 4 times 4 is 16 times 2, which equals 32. Therefore, the fifth root of 32 is equal to 2. If we took 2 to the fifth power, we would get, 32, not 36. Sorry, guys. Okay, so that's how you would solve problems with higher roots other than the squared. Go ahead and pause the video, work through these on your own paper, and then come back and see how you did. We're taking the third root of 27. Once again, there aren't very many things that divide into 27. 9 does, but 9 squared is way more than 27. But 9 is divisible by 3, so let's try 3. 3 times 3 times 3. That's 9 times 3, which equals 27. That's what we want. So the cube root of 27 is 3, because when we cube 3, we get 27. 256. This is going to be one where you're probably going to look it up on your chart there. What times itself 4 times is 256. And if you looked on your chart, you would see that 4 times 4 times 4 is equal to 256. Therefore, the fourth root of 256 is equal to 4. And once again, another one that you're going to have to look at your chart for. But we're going 5 times. So we know that 4 to the fourth is 256. Now we're going more, so it has to be a number that's lower than 4. So probably either 2 or 3. If you look at your chart, you will see that the answer to this is 3. Check your answers, make sure they match up. If not, if you don't understand, go back and rewatch the explanation. Another set of try it problems, go ahead and pause the video. Check to make sure your answers match up with mine after you work them out by yourself. So we have the cube root of 1000. So we want to know what times itself is equal to 1000. Hopefully you learn quickly to memorize or to recognize the tens. 10 to the third power is 1000, right? 10 squared, you know, is 100. And so then if you multiply that times another 10, that equals 1,000. The fourth root of 16, we know it has to be a low number if it's being multiplied by itself 4 times. The solution to that is 2. And the fifth root of 1024, that is 4. This is actually a very fun number. From this number, we get the number, if you see if you multiply it times 2 again, you get 2048, which is actually a really fun game. And I am going to have you guys play that in association with this lesson. So check your answers, make sure you are understanding. If not, rewatch the video. Let's do another example. This one, watch for negative signs and odd and even powers. Okay, so let's go ahead and go through these. Now notice, the first thing I notice is that I have a negative inside the radical symbol. Now up until this point we've said anytime you have a negative inside there, it's not a real number. However, we're not working with the square root, we're working with the cube root. Because this is odd, it is okay to have that negative inside. So we want to know what times itself is equal to negative 125. And if you look at your charts back a few slides, you will see that it is negative 5, right? Negative 5 times negative 5, negative 5 times negative 5 is equal to positive 25. But then if we take that positive 25 and multiply it times a negative 5 again, that equals negative 125. That's another one that you should have memorized. You should have the 5s memorized. The next one is the fourth root of 16. There's no negatives to deal with, so we're fine. We know it has to be a low number, so let's go ahead and try 2. 2 times 2 times 2 times 2. That equals 4 times 4, which equals 16. So therefore, the fourth root of 16 is equal to 2. Here we have another negative, but we're fine because we have an odd root here. So we want to know what times itself 5 times is equal to negative 243. Hopefully you will reference your chart when you have problems like this, and the solution to this is negative 3. Negative 3. Okay, you guys are gonna do some try it problems. Go ahead and pause the video and then come back to check your answer. So the first one, we have a negative, but we're fine because this is odd. And so what number times itself times itself times itself is equal to negative 27? We know it's going to be a negative number, and we just recently saw that 3 times 3 times 3 is 27, so we know that it's going to be negative 3 for this one. Now we have another negative number inside the radical symbol, but look, we have an even number here, an even root, so we know that this can't be. This is not a real number. Not a real number. And that would be the answer. Here we have another negative, but it's okay because we have an odd root there. This is an even number, so I'm going to guess negative 2. Negative 2 times negative 2 times negative 2 times negative 2 times negative 2. Wow, that was horrible. Negative 2. These two together equal 4. These two together equal 4. And then this one's by itself, negative 2. So I have 2 times 2 is 4. Sorry, I wrote 2. I said 4 and wrote 2. 4. 4 times 4 is 16. And I'm going to multiply that times negative 2. And that equals negative 32. So we know that our fifth root of negative 32 is negative 2. Check your answers. Make sure you understand why the answers are what they are. And one more try it page for you. Go ahead and pause the video, work through these, and come back. So we have a negative inside the radical, but we have an odd number. That is totally fine. You should have gotten, by referencing your well, this might not have been on your chart. You might have had to do this manually or with your calculator. And we'll talk about how to do these on your calculator later. But you should have gotten negative 6. Here we have a negative inside, and we have an even root, which means this is not a real number. Not a real number. So it would be imaginary. We'll get to that later. Here we have negative, but it's odd, so it's okay. And if you checked your chart, you would have found that the solution to this is -4. The fifth root of -1024 is -4. So if you got any of those wrong, go back and make sure you understand why they are the answers that they are. If you need to rewatch any parts of the video, go ahead and do that. Check Google Classroom for your assignment and let me know if you have any questions.